Hello, everyone. I just wanted to take a moment and talk about the slicer, talk about some of the use cases you can use the slicer for. Some things you can't model, and sometimes you have to use the slicer in order to manipulate your model to get it to print the way that you want it to print. Firstly, we'll go over just some of the layout of the slicer. For one, let's go ahead and get in the habit of turning on advanced in our settings. This will show a lot more settings than what the basic settings do. And I highly recommend getting at least semi-familiar, at least with the layout of where some of these things are that we're going to be going over. You don't necessarily need to remember every single thing, and don't try to memorize all of it. There's going to be too much. But just some of these tools, they're good to know where they are at. So the first thing that we're going to see whenever we come into prepared from after the home screen is going to bring us into our plate where we have our viewport, and we also have this little side panel. The side panel will have a lot of your various settings that you can change. If we go to the top, we notice this is where our printer is going to be. If you are going to buy a printer and you decide to use Bambu Studio as your slicer, you can add and remove printers by coming down here to select remove printers. Your printer may or may not be supported, though there is a wide variety of printers that Bambu Studio does support, as you can see. And you scroll down, there's Anycubic Reality printers in here, Elgo, and many more. After you find the your printer, if you're doing this at home, you just check mark it and hit confirm, and it will load a profile for your printer. In class, we have the A1 Mini. We also have a P1S, a P2S, are the other two printers we have, as well as the Ender 3 V2. To the right of your printer, you will notice that it has your bed and what type of bed you're using. Most printers nowadays come with the textured PEI plate. It's most likely going to be the default, but they also come in a variety of other textures: smooth plate, high temperature plates, cool plates. There's some other ones you can get that would probably just fall under the smooth plate that have a pattern on them. You can get, and I would just use the smooth plate if you choose to use one of those. In the class, though, all we currently have, though, is these textured PEI plates for the Bambu printers. Next, underneath that, we're going to see our nozzle diameter and the flow. All we're going to have in the class is a 0.4 and the standard flow. If you get a printer of your own and you start looking into the nozzles whenever you're slicing files, just make sure that you switch this and just to be consciously aware of it if you start messing with nozzle sizes. Underneath that, we will see your filament section. If you're using the AMS or other color changing adapter for a printer, this is usually how you add them. There'll be a plus or minus. There's also the synchronized filament from AMS. If you're printing at home and you have a Bambu printer, if you press this, it will synchronize what filaments you currently have loaded into your AMS and what you have this set at, and will automatically pull them up here. Whenever you're going to go and change different materials, just try to make sure you're using the correct profile. Sometimes you will get filament that does not fit into these generic profiles. If you start noticing you're having a lot of issues that you can't diagnose otherwise, a lot of stringing, maybe filament breaking, or a very poor extrusion, or under extrusion, or over extrusion, it could be from a setting to do with your actual filament settings. If you stick with your more name brand filaments, Bambu Labs, Sunlu, Hatchbox, Voxel, there's a couple other name brand ones you can stick with. Your generic profiles are going to work pretty well. But occasionally, if you run into a not so well known filament, there may be certain settings that you need to change for your filaments. If you need to change and make a custom filament, you can come in here and add remove filaments. There'll be tons of different filaments in here, a couple different brands. But if you ever have to come in here and create one, this is how you would do it. You would come to custom filaments after that drop down, and you would pick one of these vendors. There's a lot in here to pick from, but so the vendor you have may or may not be in here. There's a lot more than just these. Once you pick your vendor, you would pick what the filament is. There may be some also the series, basic, matte, silk, carbon fiber. Those types of things is what you would put in here. You can also create a profile based upon whatever your current filament is right now. So let's say I needed to build one that was based upon PLA, but I just needed to change some temperatures and stuff. A lot of your flow rates and stuff are going to be exactly the same. So you can do that, but for right now, what we're going to do is pick a random filament, or we'll go Sunlu. Sunlu's a good, and let's say some carbon fiber ASA. Series, please input. We'll just do basic for this. And we can base this off of bambu's filament, and then there's going to be a bunch of different nozzles. It's important that if you're having to input information for your filaments, that you pick all of the appropriate nozzle sizes that you're going to be using for it. Otherwise, you'll have to come redo this step if you're ever switching to certain nozzles. I do want to point out, though, that this ASA CF, which is carbon fiber, you only see the smallest size nozzle being 8.4. That's because carbon fiber has a tendency to back up in smaller nozzle sizes, so they just don't have profiles for those. Okay, now let's go ahead and get to importing a project. I'm going to go ahead and use the A1 Mini as our example here. Or actually, I take that back. Let's do a P1S, because I happen to have one of those here at home as well. Let's import a model. We'll use the monitor stand that I designed, and notice something here that it's too big. And the way that I modeled it and I imported it, Bambu Labs sees all three pieces right now as being a single model. This may happen from time to time whenever you import a file from the internet somewhere, and that's okay. There's ways to break it apart. If you just have your model selected like I do currently, and you right click it and you come down to split and to object, you'll notice that some of it looks like it disappeared. It didn't. It's now all just on the same plane because it split them down into individual pieces. So I can come in here and click them individually and pull them apart. All right, great. Now I want to talk about our process tab over here for a moment. And you notice how there's a global setting and object setting. One of the cool things about the object setting is this allows you to do something that I haven't shown any of y'all yet, but you can use it to do multiple things. And that's modifiers. To add a modifier, you're going to left click on, you're going to left click on your model, and you're going to scroll down to add modifier. These come in a couple different shapes. For this example, we're going to actually do it on this piece right here, on this top billet right here, because that's the part where I'm going to want this to be the strongest, because that's where the monitor is actually going to attach. So to do that, let's right click, go to modifier, Let's do a cylinder. You'll get this message right here. Switch to per object to edit the modifier, and that's exactly what we're going to do. Let's change the shape and size really, or the size of it. Let's scale it up. Let's go to 400%. There we go. That'll give me. Actually, let's do 200. 200 should be fine. Maybe 300. So we just kind of figure out the sweet spot of what you need. Okay, that size looks about right. Let's move it up. So you just want this to go over your part in the area that you want to have separate settings than what the rest of your model. I've got it pretty good. I might go a little bit higher here. Right there should be good. I can unclick that. Now let's just go start setting up our settings, and we'll come back to that whenever we switch it. We're going to come through. We're going to switch a few settings on all of these pieces individually because we're using the modifier, and we're going to be printing them all at the same time. So this first piece down here, we'll go over to quality. I'm going to keep it at 2 millimeters. If functional parts are honestly stronger, the fewer the bigger your layer is, because there's less points of fusion that has to happen in between layers. That's going to be your weakest point, is on layers, the in-between points. That's your weakest part on all of 3D printing. So the thicker your layers are, and thicker that your extrusion is, then the stronger then it's actually going to be overall. So there's upsides to keeping large layer lines, even though you can visibly see them. We are going to go ahead and scroll down, though. On the way, I'm going to talk about a few settings as we go down. Seams are usually hidden pretty well by the slicer, but sometimes you can still see them under certain circumstances. Actually, we'll go ahead and hit preview right now, so I can point it out to you on where it is. Right here is a seam on this model. Each layer has to have a seam. It's kind of where the two ends of a layer meet on your outside wall. You can do a couple things to make them less noticeable. One thing you can do, which is actually just standardly done now, this has been fairly recent in the last, I guess this last year, was having this setting standardly turned on by default, and that's the scarf joints. Scarf joints make them far less noticeable whenever they aren't on a corner, but lots of times whenever you have a hard outer edge, the seam will get hit in there. If you are working with a model that is more organic looking, more on the artsy side, and you're getting a really bad seam and it's really hard to hide it, if you go over to seam position and you go to random, and we'll see kind of what this does right now. It works a lot better on other organic things, but if you notice all these dots, that's each layer having its own seam and randomly on the wall somewhere, instead of having them all line up down your whole print. This can get you a better result on certain types of models, but we'll go ahead and turn that back to the aligned for right now. Scrolling on down. Elephant foot compensation. So we do encourage you, while you are designing parts, to chamfer your bottom edge so elephant footing is less likely to happen. If you're working with a model you're pulling off the internet, or for some reason the bottom edge can't be chamfered, you can try messing with this amount and increase it and decrease it in order to get the right amount of shrinkage on that first layer, to prevent any warpage of your part. Ironing. Ironing is very helpful to get a very nice top finish on your part. It'll be very smooth. That said, the higher up you use ironing on your part, there's a higher likelihood that it's actually going to score your model and actually make a artifact on your print. Your mileage may vary, but it's really good for making things like signs and stuff that are going to be flat. Wall generator. Wall generator, there's two settings here. There's classic and arachnid. Basically, the difference is classic supports older firmwares such as Marlin, which is an open source firmware for some older type of printers, such as the Ender 3 V2, the ones that we have in the back of the classroom. But the only problem with doing these is there's certain geometry that will trip this up, and it won't generate correctly for your actual layer line pathing. So I don't know why that this hasn't just become the standard for generation. But I always switch this. You don't have to. Your mileage may vary. Let's see. Outer walls. This is going to determine your wall order and the order in which they get printed. The reason why this is important is because on certain filaments, you may notice your infill pattern. You'll be able to see lines in lines from where that attaches to the inside wall on the outside of your print. If you leave it on inner outer, it's technically a little bit stronger doing it inner outer, but if you want a better surface finish, doing outer inner is a way to accomplish that. If you notice artifacts, that kind of how I'm describing them. Bridge flow. So let's talk about for what a bridge is really quickly so I can better explain that setting. Right now, a moment ago, I was getting a notice that I need to turn on supports because there's some floating areas on my print. And here is one of them at these bottom layers right here. Also, anytime you need to manipulate this in order to see what layer you're working on, if you notice this bottom number right here, it'll tell you what, this bottom section right here, it tells you what layer it is and the layer height. Knowing that if you start to have a problem with a print for a varying reason at a certain layer height, you can actually measure it out using a ruler or a pair of calipers, and then come back in the slicer and then maybe change some other settings at that layer height using a modifier. This is exactly what we're going to be doing here, but this is going to be for making a part stronger. But you can also use it if you're having issues at a certain height in your part by being able to manipulate other settings in just that section. So for bridging, if we notice, when I go to this level, and just the one right above is whenever I have this fill in. These lines going over a open area to this other side, that's what bridging is. You can actually print something this way. It's just you need to change a couple settings to get a good finish on it, and it's going to vary a little bit. Usually, in order to get a decent a decent amount of bridging over a larger area, especially larger like this is a pretty large area to cut across. You would change this down to a 0.85 is what I would do, a 0.9, and somewhere in between there, I would add or subtract just a tiny bit from that general area. And you may have to print something once or twice, or just print the area of something once or twice in order to get these settings down. If you ever are having trouble and you need to print a certain section of a print so you're not wasting all the material, you can come over here and you can set pauses So let's, don't know why it went away. I guess it moved a little bit. Okay. Um, let's say I just wanted to print this one section of this part for this bridging right here, and for me to dial in. Set it at that layer height, and I come over here, and then I can do a add pause. So whenever I run the G code and it gets to this point and it's done, it'll stop. And I can evaluate it, and then I can stop the machine altogether if I want to and change some other settings and re-upload a file again. But for right now, we'll go ahead and get rid of that. And we'll actually go ahead and get rid of this bridging because we are going to use supports for this. All right, going from the quality tab over to the strength tab now. This first thing you're going to notice right here is your walls and your wall loops. Most slicers default to 2 wall loops. I like doing a little bit more, especially on functional parts. And this will kind of vary depending on the orientation that you're putting something, the shape of something, and you're just going to have to learn, but do it with some form of idea of where your stretch points are going to be on your part. Kind of give it a little bit of thought. I know that this is going to be attached at 3 different points. One right here to here, and then here to here. So there's going to be a lot of pressure being put here, and here, and here, 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 and here. And a little bit on these rings. That's going to kind of hold everything in place. But because I know that there's going to be strains on those parts, especially this piece right here, I'm going to want to up my walls 4 or 5 on this, probably. But for functional parts, I recommend at the very least 3 to 4. Okay. Let's talk about this top surface pattern for a minute. If we do a preview here, and we go back to the very top of our model here on the side, we notice that this pattern at the top goes in a certain direction, all the way across on all the tops of the models. That's what this setting changes. Changing these doesn't really change the strength of your part very much. They will change the top surface finish. And for certain shapes, certain ones look better than others. If you're trying to make something look like something that it isn't, like wood or something like that, this is a good way to kind of add a little bit of surface detail without the detail actually being in your model. There's another way to add a little bit of detail inside of the slicer that I'll show you later on. But for your surface finishes, this is what choices there are. I personally like concentric a lot. It looks really well. It looks really good usually on most all parts. Get a little bit of a pattern in here. I just think it looks it generally looks pretty good. Your top shell layers, this is going to be how many layers before your top surface. So we come down here, we see that's where it starts to shell right here. So we got 1, 2, 3, 4, 5. That's the top of the layer for right here first, and then it's going to continue up as this stair steps up. Your bottom surface pattern is the exact same thing as the top surface pattern, just on the bottom. This can play a little bit of a role in adhesion. I usually leave this alone. You can change it. Your mileage may vary. Okay, let's go to sparse and fill. This is going to be this pattern that you notice as I go up and down on the slider and you see on the inside. And I'm sure by now, if you've watched any of your print, that you'll notice that there is a pattern on the inside. This is where you would go to change that or increase the amount of infill that you have. I know there's going to be some logic there's be some counter logic that I'm about to give you, and that's counterintuitive to what you would think, and that's having more infill doesn't actually make your part stronger. In certain scenarios, wherever you want a bunch of material, if it's going to be something that's going to be getting banged up a lot, then having a lot of infill can be a good thing, or even a solid infill I've done for certain parts. This is how you would change that. But if you go to the sparse infill pattern, you'll notice that there's a lot of different infills you can use. Actually, I think they've added more since the last time I've really taken a good look at these. There's a couple I do want to talk about though that do matter for strength. A couple of these others are just for artistic purposes. Grid works really well most of the time. It's very easy for the printer to bridge off of it for top surfaces and a few other things. It's okay. It does have a little bit of a flex to it though. Gyroid is one that is my kind of my go-to. It is a geometrical pattern that is very strong. It's very strong, and I'm looking at the wrong part here. Here we go. It's gonna be this one right here. Okay. We'll go back and change the rest of those settings here in a minute whenever I talk about modifiers. Gyroid's kind of my go-to. It's very strong. It's got good dimensional strength in every dimension. That's the one reason I like using it. A lot of these infill patterns will have good strength in two of your dimensions, but not in your Z dimension. Just keep that in mind. There is a cool trick I'm going to show you, though, right now, if you're ever working on a part that you want to be able to see the infill. So you can do a trick here. Go up to your walls and turn this to a 0. And then whenever you prepare the top layers of your part, you'll notice won't have any infill. Or, well, I'm sorry, well, they won't have a top surface, so you can see your infill. It's kind of a neat little thing you can do. And why some of these other ones exist. Actually, let's check out Zigzag because I don't remember this one. It looks to be just a cubic one. Okay. Well, we'll turn that back to just grid. Or actually, I'm going to go back to gyroid. There's that. Speed. Most of the time, you're going to leave this alone. There is a scenario in which I recommend looking at this page. And that's if you're using a bed slinger. And this is also the reason why you should probably pay attention on how to use modifiers. The way that I'm going to be using modifiers is going to be it's going to be changing the infill of this top part right here. But you can also use it to change your speeds. Let's take a minute and talk about a bed slinger really quickly. The printer I've selected isn't one, but let's say it was. For sake of not messing up my bed right now, I'm just going to use this as example though. If I grab shift and, or I'm sorry, if I just grab my bed right here with my scroll wheel, I move it back and forth. That's imitating the direction in which a bed slinger is moving for your Y plane. The reason why this is important is because the taller your part gets, all of this is wobbling a tiny bit. And the printer's trying to compensate for it, but there's a certain point where it can't compensate for it anymore. So you would find out what layer height that is by measuring it out, making a modifier, how I showed you to do before, to find the right height that you want it at using your slider on the side and setting that modifier. And then you would come in here and you would reduce a lot of these. You don't have to do all of them. It just depends on what's going on in the model at that point. But most of these would get reduced, especially these bigger numbered ones would get reduced by 50%. The percentages you would leave alone, but these bigger millimeter numbers, you would go ahead and turn those all down by 50%. And that will fix some of those issues. All right, now let's move over to our support tab. Support tab, the first thing you're going to notice is Enable Supports. Novel place for that to be, I know. Okay, now if we go down to Type, we will notice on this drop down that you have Normal, Tree, Normal, Manual, and Tree, Manual. The difference between the auto and the manual is the manual you need to print, you need to paint those supports onto the model before you slice it. I'll show you how to do that in a moment, but just know that that's the difference between those. The difference between the normal and the tree supports, as some of you may noticed on models that use supports, the tree supports look kind of like trees. The normal supports are rectangular in shape and aren't used as much anymore, but I find to be really helpful to use on things that are, geometrically shaped. So parts of your clamp, this right now, actually, I would use the normal supports. I don't see any point in setting custom supports on this because I don't think that I can do a better job than what the slicer is going to do for setting supports for this. However, sometimes the slicer is a little overzealous with the supports, and sometimes parts will print perfectly fine without supports in certain areas, but we'll need them in other places, and then that's when you will need to paint them on. Moving down, we'll notice these raft layers. I'm only bringing this up because if you take home one of the enders, you may find it very difficult to print. Turning on a raft may or may not help your print. Generally, that's not something that's used anymore, but on those older enders, it can be something that can save your print and make it printable. Basically, what it's going to do is your print is going to be printed on top of another piece in which you can indicate how many layers that's going to be set here. And also for this is the one reason why this doesn't get used as much anymore is because we have heated chambers and such. If you were to be trying to print ABS on a bed slinger that didn't have an enclosure, you would probably be trying to print something on a raft. All right, filaments for supports. This is something that we haven't gone into, but it's something we technically have the ability to do at the school because we have the AMSs. You can use a separate material as your supports, or at least the support interface. The reason why this is cool is because certain materials do not fuse together. Namely, PLA and PTG. You can actually use PTG as a support interface for PLA and vice versa. The benefits to doing this is having a really good finish on your part if you have enough surface area where the support's going to be. That's the downside I've noticed to doing this, is that if you don't have enough surface area of your top part, let's say it's PLA and your interface layer is going to be PETG, if you don't have enough surface going along your PETG as the PLA, since they don't fuse together, it won't adhere to it, and you might have a print failure because of that. So if you ever do this, just make sure that you're using it for places where you're going to have a significant amount of interfacing between the PTG and your PLA. Now we'll scroll down to advanced settings. There's just one setting I kind of want to come in here and talk about, and that's going to be your top Z distance. That's going to be the distance between your support and your first layer of your part. Normally, it's set to whatever your layer height is that you have set in the slicer. Right now, it's set to 0.2. That will print the part well, but you may have difficulty getting off your supports. And in certain scenarios, you may break parts of your model if it has small features that have to have a support because of it. I recommend increasing this by 0.05 to 0.1. I personally do 0.07, and so if I came in here, I'm going to just add a 7 to that, so it'll be 0.27 millimeters, and that's how I'm going to set that. Now, remember, I've only set settings for one part. So I'm going to go ahead and set the rest of my settings, and then we'll talk about setting the modifier. Okay, now that I've gone through and I've individually set the settings for each piece to this print, I have come back and I've now to this cylinder that I set. What this cylinder is going to do and what a modifier will do is it allows you to change the settings for that part of the model that is inside of the modifier. So it'll be this top part right here. So what I mainly want to do is come over here to strength, and you know how I said you can print certain things solid? That's exactly what I'm going to do. We're going to set that to 100. It's going to say I can't do gyroid, so we'll turn it back to rectilinear, which is fine. But if we come here back here to preview, we scroll up to that part, we'll actually see where it's going to start printing solid. Just right there. That means that billets can be relatively strong in comparison to the rest of this print. Oh, actually do need to come in there to these settings for that part right here and turn the wall or the top surface back on. There we go. And that's kind of how to use a modifier. It takes a few extra steps, especially setting all of your settings for your individual parts. One thing actually I'm noticing right now that I'll point out in supports, because I'm getting some supports right there when I don't need them, is on build plate only. We'll keep the supports from generating on your model. I actually have to come back in here to this. It's not in the modifier. Pull plate only. There we go. Preview. Let's take a moment and talk about the others tab. Some of you may have already used a brim, or I may have suggested using a brim on some of your models. It's really good to use on things that have sharp corners. Usually 3D printing doesn't like sharp corners. That's where you'll have a lot of adhesion issues. You'll have your corners want to curl up on you. So we'll go ahead and turn on the brim real fast to see what it does. There's a couple different types. I've suggested doing an outer and inner brim to a lot of you. This is a good way to go if you're not using a painted brim. I do recommend using a painted brim though over the regular inner outer brim, but the inner outer brim's just an easy setting to turn on if you're not worried about saving filament. But if you notice that there's this outer perimeter that gets put down of filament, that just helps the outside corners of your print stay adhered to the bed, and you can usually peel them off really easily. But let's go ahead and look down here on the special mode really fast and look at fuzzy skin. Fuzzy skin is a good way to give a part some form of texture whenever there isn't any on parts. I do recommend painting this on and not just doing all walls, because then you may have fitment issues if there are parts that go together. We will go ahead and turn that on, and actually let's turn on painted for the brims as well, and we'll talk about this little bar up here at the top whenever you're in preparation. As you notice, we've used it to. You can use it to import your parts. You can also auto orient if you want to. We'll orient your whole bed. If the whole bed is already pre-oriented. Whenever you load in a part, this is the way to unlock it. Now, this setting right here. Oh, actually, some of these, I'm sorry. Some of these I can't use because of the mode that I'm in right now. But we'll talk about them. Variable layer height is really good to use on certain parts. Usually, circular parts on your top layers or layers that stair step up don't look very good. But if you turn on variable layer heights on a model, one of the benefits to this is in those areas it will use a smaller layer height to get more detail in those areas so it doesn't look as bad. And we have already you may have already had to use the move tool before, or the rotate tool, or the scale tool. All these do exactly what they sound like. Also, this lay on face, if you need to reorient a part, this is how you would do it. You would use lay on face. I do recommend whenever you import something from the internet, you take a moment and you consider how it should be printed or the best way to print it to get bed adhesion or print detail, depending on which you're trying to go after. You can also cut parts in half if you need to. We try to encourage you to do these things inside of Fusion, but if you just need a quick cutting tool, this is helpful. Some of you have done multicolor printing, so you may have already used a little paint can to paint on your multicolors. This is how you go and change to add different colors to your parts. If you wanted to do an embossment on a part, you could technically do it with this text shape. We also, yet again, would recommend you do these types of things in Fusion. For painting on supports, if I wasn't using auto supports, I would come in here and press this tab, and it'll isolate the part that you have selected whenever you press this, just like it does with painting. And you would press the part, the places that you think it would need supports, which on this part aren't any. But let me pick one of these others and we'll take a look at it. It's mainly going to be these parts right now that it's already highlighted. This is the parts that it's seeing, as you can see with this pattern, that it recommends that there be supports put. So I'm actually already cool with that, so we're just going to let it ride. Okay, there's one more paint. There's a couple more paint tools here to talk about. Here is brim ears. This is what I was talking about before, how your brims, how you have different types, and if you do paint it, then we're going to do the ears here. Let's increase the diameter and put some right there and see what this does. There we go. This little brim will hold down these lines right here for these walls pretty well, especially in PLA. This is more than enough to hold this part down. I recommend using these on hard corners or edges that are likely to pick up and curl. Now let's go back to prepare, go over to your fuzzy skin painter, and just how you have a fill tool, a circle tool, a sphere tool, and a triangle in your other paint tool. They're also the same here. I'm just going to use fill and use the outside surface. And then we'll come over here and preview. And you'll notice that the outside texture of this has changed. This is a good way to get a little depth on parts, especially on geometrical parts. I do recommend that you paint this on and you don't do the entire part, especially on parts that have mating pieces, because it does change the geometry of your part and they will not match up and fit. There's also a measure tool in here. If you need to use a measure tool, you can just pick a surface and pick a second surface, and it'll tell you the distance between them. So, if you were having trouble using the slider method that I was talking about, you can also use this measuring tool to get measurements. So if you need to change certain settings at a certain point, you can compare where you're having problems on prints and where you can just pick a point on your model as well. All right, well, I hope some of this has been helpful for some of you going over some of these settings. Slicer is always kind of a good thing to wrap your head around, having a little bit good familiarity, and I recommend just playing with it. For one, you have the viewport. If you go in and change something, you can kind of change it and see what it does. I do recommend kind of sticking to some of the parameters I've pointed out here, just so you don't have any print issues. But I encourage looking into and seeing what other settings do as well.